So let's say that I wanted to find the average rate of change of the function f of x from the interval from 2 to 3. So f of 3, I need to evaluate this at x equals 2 and x equals 3, so that's just 3 times 9 plus 5, which is 27 plus 5, which is 32. And then f of 2 is equal to 3 times 4 plus 5, 12 plus 5 is equal to 17. Now I can find the average rate of change, which is equal to 32 minus 17 over 9 minus 4. Not 9 minus 4, sorry, 3 minus 2. We squared that, so it's 3 minus 2, which is equal to 32 minus 17. What's that equal to? That's 15 over 1. It's just 15. That's our average rate of change. Okay, let's do another one of these. Let's say that I had the function g of x, and let's say g of x equals 2x squared plus 5x plus 3. And I wanted to evaluate this at, or I wanted to find the average rate of change from 5 to 10. And the average rate of change from 5 to 10 is basically the slope of the secant line going through the point x equals 5 to x equals 10. Something like this, and this is just an example, and the function would be going through these points, and it would go like something like this. So this is just one example of how it would look, but this is essentially the basic idea. We're finding the slope of the secant line going through the point x equals 5 and x equals 10. That's the average rate of change. Okay, and so this is just g of 10. We need to evaluate that at the 2 points. So g of 10 is equal to 2 times 10 squared is 100, plus 5 times 10 is 50, plus 3. This is 253. And then g of 5 is equal to 2 times 25 plus 25 plus 3, which is just 50 plus 25, 75 plus 3, 78. So this is 200, this is the average rate of change, or the slope of this secant line going through x equals 5, x equals 10 with the function g of x, is going to be equal to 253 minus 78 over 10 minus 5, which is just 5. So what's 253 minus 78? So 253 minus 78 is going to be equal to 175. 175 divided by 5 is just equal to 35. And that's the average rate of change of the slope of the secant line going through x equals 5, x equals 10 through the function g of x at those 2 points. So in future videos, you'll be looking at the instantaneous rate of change. So that's the rate of change at a single point. That's the slope of the tangent line in future videos, which is also called the derivative. So it's also called the derivative. Hope you found this video helpful.